All right. So if you're finding independent events,
Whose turn is it? Kylie's. It's not Kylie, you're not playing. Hey, no, you're not. Where?
okay? Shh. Quiet. Put the iPads away. Independent events means they don't affect each other. Like the probability of rolling, if you're doing dice, a 1 and then a 5. The first roll doesn't affect the second roll. And this could be if you rolled it 7 times. So the probability of rolling a 1 is?
1 out of 6.
And the probability of rolling a 5? 1 out of 6, right? So all you do when they're independent is you just multiply each probability. So it's just 1/6 times 1/6 is 1/36. Okay? Doesn't have to be just two things. Say you're flipping a coin, and they say, what's the probability of doing this? Flipping a heads, and then a heads, and then a tails, and then another head. So there's 4 things happening. None of them affect the other one. So the probability of this is 1/2, this is 1/2, this is 1/2, and that's 1/2. So all you do is you multiply the probability of each one. So top times top times top times top. So that's 1/16 is the probability. Yep.
Wait, so couldn't you just like square it if it's like the same thing?
If it's the same thing, yeah, if you're just doing it twice. Or here, since it's 4 of them, you could do it to the 4th. They won't always be the same probability, though.
Why is that 1/2?
Because when you flip a coin, you can either get heads or tails. Okay. Dependent events are a little bit harder. You got to take the probability of the first thing times the probability of what would happen without the first thing. What that means, P/A, it's easier if I just do this example, then you can see.
Are we in the book?
Not really. This is kind of a supplemental.
Is that what we're pretty much in here?
So is this the last thing we're doing?
Not really.
Or something come up?
This one and then one more.
So we have 2 tests.
Are there actual tests or do they those little 5 questions?
This one won't be a big test now.
Well, just kidding.
So
Okay.
what?
So what this is then is it's really the way they got it written. It's kind of complicated, but it's not as hard as what it looks. What's the probability if there's 9 whites, 7 blacks, and 5?
20. 1 out of 20.
This is supposed to be
9? What?
5.
5 blue. Okay, so this adds up to 21. So this is what they're telling you to do. At event A, you choose a white one first, and then in B, you choose a black one second. That's what that is, second. So, what's the probability of the first event?
1 out of 21.
9 out of 21? And then, again, we're going to multiply it. Now, what this one means is the probability of B after you've taken A out. So what that means is it's not being replaced. That's all that this means. So what's the probability of this happening?
Something out of 20.
7 out of
Right,
21.
there's 7 blacks, and now there's only 20. So that's all it is. It's really the same concept. It's just you got to subtract one off because one is taken out and not replaced. So when you do this, it's top times top, bottom times bottom, but you're going to want to simplify. You can cross cancel here, 7 goes into there once and into there 3 times. So top times top is 9, bottom times bottom is 60. So it's 9/60ths, okay? I think that's it. Those are the only ones we're doing today, yeah?
I guess.
So, I've gotta make a copy for you.